Hello everybody and welcome back. So today we're going to be back again with Advent of Code. We're going to be doing the next day's challenge, so it's day 2. I feel like we could probably do something here. So we've been launched to the atmosphere. The apex of your trajectory just barely reaches the surface of the large island floating in the sky. You gently land in the fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you'll have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play the game, he will hide a secret the number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. To get information, once a bag is loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You play several games and record the information for each game, your puzzle input. Each game is listed with its ID number, like 11 in game 11, followed by a semicolon separated list of subsets of cubes that are revealed from the bag, like 3, 5, 4. For example, the record of a few games might look like this, right? This is going to be our example input, probably. In game 1, 3 sets of cubes are revealed, or whatever, they explain it here. Alright, the alpha would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. Right, so for example, game 3 wouldn't be possible, right, because there's people 20 somehow, right, but 1, 2, and 5 would be possible. However, here we have 15 blue cubes in game 4, so that's why it's not going to be possible. Also, we have 14 red cubes, so it's pretty apparent. In the example above, games 1, 2, and 5 would have been possible if the bag had been loaded with this configuration, so it's 3 and 6, so that's 9 blue, 4 and 1, that's 5, 2 and 2, that's 4, possible, right? And we can, again, they say game 3 would not have been possible because they have showed 20 red cubes at once, and only game 4 would also not be possible because it showed 15 blue cubes. If you add up the IDs for the games that would be possible, you would get 8, right? Because it's 1, 2, and 5. So now they basically ask, determine which games would have been possible if the bag had been loaded with only 12 red cubes, 13 green cubes, and 14 blue cubes. What is the sum of the IDs of those games? That's basically our goal for today. So, of course, now that we've read the challenge, it's time to actually pick a language. So let's spin the wheel and see what we get. JavaScript again? Well, let's make it a little bit more interesting. We're going to again spin the wheel and see what we get. If it's I'm happy with it, honestly. Cool. I think we already have a GCC compiler on our machine, so I think it's time we get started. Let's actually check out. Okay, we have GCC. That's all we need, basically. Let's go to D. Let's go to Programming, Advent of Code, 2023. And let's make a directory called day 2, right? So day 2. I think we're going to be using make, since I already have it on my machine, but you don't really need to use anything that's interesting, right? You could use anything at this point. Let's actually make the input files and actually main.c and maybe the make file itself, and let's open up new of them. Okay, so we're going to have GCC as our compiler, C flags, not really anything, and let's actually get the source files, which are going to be basically a wildcard of all C files. basically all C files in this directory. So yeah, this and basically output can even make is going to be main. Or it would be kind of interesting if it was like out main, because right, we probably need to have it a little bit of organization if we want this to work. So we're going to do -o output. If you don't know, it's basically this is our C compiler, right? GCC. These are the C flags. This is the output directory, and then we just do source files, right? We want to compile these files, which if we check out the current directory, right, we only have one that's going to be main.c. If we had another file, like for example full.c, it would also be included in the final build. So right, let's actually make the output directory because it's kind of important, right? Because we output to there, and I guess you can probably make like a run, or not. I can just do this. Maybe that's probably enough right now. I would probably want to strip it and have some optimizations, and that's about it. So if we now edit our source file, we can probably even move it into its own directory, right? So move main.c into source, and let's actually edit source main.c, and let's do hashtag include standard layout.h main void def lower out, and we can just return 0. And now if we compile this, so make dist and out main, no input files, really? Let's oh yeah. So let's actually select all from source, right? Because we put the main file into source, and that's about it, right? So let's run it again, and actually probably add like a run command that basically just runs the output. Making this and make a run, and yeah, we get a hello world. So we probably want to get the input files that we need. So let's actually make like a input.txt file, and let's vs with that input.txt. Let's copy the game one's data, so this, and we can paste it in here. That's it. And let's edit our main file, right? Let's actually quit this and vs with source main.c. So the first thing we probably want to do is have a function that can read in the entire file. So read entire file, and we probably want to have like the path and way to get the size itself, right? Or even yeah, that's a more simpler way to do it. So what do we do? Well, we have our file f equal to f open path as read bytes. If not f, or f equal to no, that's a little bit more readable maybe, we can just return no. And then what can we do? Right, we've opened up the file, and we can get the size, so we can do fseek f on file end, or how was it, like cursor end? I don't quite remember. Let me just Google it up. Seek to file end in C. Seek cursor, so seek end. That's it. Seek end. And this can fail, for all I can remember, if we open up the manual for fseek. Well, it's not really Linux, so we can't really do that. So we might as well just search it up. So CPP reference, that's a good way to find it. So it, oh yeah, right, so it's the cursor is secant, but the offset is 0, right, from the origin. Okay, so it returns an integer upon success, a non-zero value otherwise. Okay, so basically if this returns something, we can just return no, and also probably close the file, close, left, and we stick to the end, and then we fdel, f. It is going to give us our size, and we're going to basically write it to the size itself, and then we can do basically fseek of f to 0 to seek seek start or seek begin. What was it? It was seek set, right? Again, this can fail, and if it does, we can just f-close f, right? It probably won't fail, right? But just in case. We have the size, right? So now we need to have malloc, right? We need to malloc the bytes, the buffer. So we have the buffer equal to malloc s plus 1. Essentially malloc a little bit memory, right? We need to at the end return the buffer, but before that probably have to f-read it. So we can do something like what? We can have while s, right? While s. So while we have some sort of something to read, we can do what? We can probably just okay, so we have like an offset equal to 0, right? So we can do f-read on f with our on the buffer with a size of a count of 1, and it's actually going to be 1 and s, right? So that's it, plus the offset, of course, and on f, and that's going to return us our buffer, or actually the amount of characters we read, count, and offset minus equals the count, right? Plus equals the count, so we want to add it, and s minus equals the count. But of course, if this errors, we need to actually kind of get that error. So we can do, if f error on this, we can probably just free the buffer and just return no, right? And also close the file. Otherwise, we've read the entire thing, plus the offset s1, okay. And this is probably not going to work, actually, now that I think of it. Or actually it will work, most likely. And let's actually do something like get the string, and let's actually do something like buffer at s is equal to basically the end character, so that way we can just do something like read the entire file, like input.txt, and we can do the size, so we can do size to 0 and just get the size, void to the buffer, and we can just print out the buffer. Buffer. Alright, and let's run this. We probably, if we get that, we should probably log something like if not buffer. I can just do something like fr, fprintf, cylinder, error, cannot read file. And I feel like we should have like a variable called path input, or basically just path input.txt, and just do path read file ls path, and just return one maybe. Alright, so now if we just run it, undeclared size. Huh? I declare it though. Oh, size t, right? Because that's from standard definition, right? Standard def h. It doesn't recognize size t. And also this. Interesting. So it hangs. Because we also have to close the file, right? F close F. Huh. And let's actually open up fread again. Fread, the manual for it. So I want to get the thing, so it's size and then count. Yeah, it's okay. So it's 1 and then size, right? 1 and then x, like this, and that should be it. Right, and now we read the buffer, right? That's kind of cool. We should have some logging if we can't really fseek, or I can't really get that, so, but I'll leave it for later. We can just write it to do log whenever you can't read file. Okay, and we can remove this. Alright, that's the buffer, right? And I feel like now that we're actually doing some parsing, we need some sort of like string views, and I almost feel like we need a library for it, but it's not too difficult to make this ourselves, right? It's not too difficult. We can just do string view. We have a buffer, and a size. Alright, probably a const buffer, view, like this, and instead of size, we can just do view buffer, and view size, and we can print out the view buffer. Alright. And slash new line, of course. If not, a view buffer. Alright, yeah, that's it. So now that we have this, we can probably have something like we need to basically get the first line from here, kind of split it by some sort of delimiter, right? And have some sort of, so maybe we can do something like parse almost the game info. So we have while the first line, right? While I can even have like the original view, and then we have like v, like the view, while v size, while v size, we can do, what can we do? Well, we can basically just take it and skip the first characters, so because we assert that they are actually game, right? View buffer plus equals 4 characters, or even 5, I imagine. 5, I imagine. And then we can have the numbers. So to parse the number, what can we do? Well, we can kind of collect the characters in another string view. So yeah, and we can even write a function that's like uint30t, because I want it to be easier. So string view to integer uint, probably. Come on, uint. So we have the string view, that is a view, and we return an integer. Alright, and what can we do? Well, we can do basically just is result 0, and we can actually do something like if view size is more than or equal to well, what character should be like the base limit, because I don't want it to really crash or overflow, but I think it's fine. Even if it does overflow, it's fine. It doesn't really matter, right? So while view size, what can we do? Well, we can just do okay, so we can just do something like view buffer, get the current buffer, right? That's the number, that's the character, and you can actually get it, so it's like a character C, right? We can even do something like if C is not equal, is not more equal to 0 and less than or equal to 9. What can we do? Well, we can basically just return 0, because that's a number, right? We can get, and it's always that. So, or we can just do something like a 0xFFFFF, and like a really big number, like, yeah. And basically now, what can we do? We can just do result plus equals C, and because C is a character, basically, to convert it into as a digit, and to convert it back to a number, like an integer, you basically just move the character part, right, which is 0. Alright, so if it was the character 0, it would be 0. If it was the character 1, it would be 1. Because right, we have in the ASCII table there are like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? This is how they're laid out. So you would remove this and you get the actual number. But we need to also do another thing, which is multiplied by 10, right? Because we want to basically stack it up to there. Or we can just return result, right? Let's write it and we just return result, and that's it. But we need to increment it, so view buffer plus equals 1 and view size plus equals 1. Like this. Or actually minus, right, because the size has to go down. And now what can we do? Well, we want to basically do, we have the beginning, so this is the beginning, v size minus equals 5. And I feel like we're doing this so frequently that we need a function for it, so like a function called skip. Or it's not, yeah, sure. String view, so it's void str skip. So we have string view sv, and we just do by how much, how many. We basically want to get that number, so we just do size t count, and we just do sv buffer plus equals count sv count sv size minus equals count. That way we can just do, and we can even probably inline it to make it a little bit faster. So now in here we can just do, instead of that we can just skip, string skip, review, and that's one. Or probably sv skip. Alright. Sv skip. And then here we can, instead of doing this, we can just do sv skip 5 on v5. And even we can even do something like if sv size is less than count, we can just, we can even assert it, right? So we can just do something like assert more than or equal to count. And then assert. Yep. As skip v, and then we get the characters. So right, we get this, and then while that's our beginning, so our base view id equal to v, right? That's where it begins, and then the while I can even do something like size ti equal to 0. While v at I, or we can even do, yeah, while v at I is digit, so dot buffer equal to 0, and v buffer at I, and then less than or equal to 9, I plus equals 1. Alright, and then id dot size is equal to that. So I is equal to I. Alright, but this feels like an operation that we can abstract away. String view sv chop. We can do string view sv chop c, maybe, and you basically have like a delimiter, and we basically just do something like a string view result to sv, right, result, but we can just do while sv at I does not equal I plus plus, and we can even skip a character, or we can just do something, yeah. Yeah, basically get that, and then we can just as the buffer, we can skip even sv skip on sv I characters, and we can just the result. That's it. The result that size equal to I. That's it. Sv chop c, sv chop c, and that's basically going to be sv chop c. Chop c into our view by this, and that's our ID. And we can now even get the actual ID, so we just do t ID as string view to u int, and we get that. And that's our ID, right part to here. And what can we do now? Well, we gotta now essentially parse an integer. If there's a comma, parse a string. So basically, what can we do? Well, we just do. Now we need another while loop. So while v buffer at I does not equal new line, because the new line indicates the end. Right, I think that's what they meant in here. Actually, here doesn't put it like 11 right here. By semicolon separated list of subset of cubes that were reviewed from the bag, like 3, 5, 4. In game 1, 3 sets of cubes were reviewed from the bag. So we have this reviewed, and this reviewed. Yep. The first set is 3 blue cubes and 4 red cubes. The second set is 1 red cube, 2 green cubes, and 6 blue cubes. And the third set is only given 2. They have first like to know which games are possible. Does he put them back in the bag? Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out the information about the number of cubes. Okay. Cubes in the elf will reach into the bag, grab a handful of cubes, show them to you, and put them back in the bag. Okay, so basically we just want to find the largest of all of them. So we can even do something like so that's the ID of our cube. We have the size t, that's our blue count, a red count, and green count, which are all going to be equal to 0, right? We can even probably inline them, but it doesn't matter, right? So what can we do? We've basically now got to skip one after we get the ID, because it's space, as we skip v1 because it's space. We can even like get the puzzle input and see if it matches. Yes, it matches everywhere. What do we want to do? We want to get the next ID, so we want to chop by the limiter, which is a space, basically count. It's actually stored in here, so we have count, which is equal to, as we chop C, like this, by the limiter, but it's actually going to be space, which would be weird. And that's our count. Now that gets us this, right? This. And then we skip one, as we skip one, right? Because we want to kind of skip it, right? And not care too much about it. And then we gotta get the next word. So I don't know why it turned my shit to this. Okay, cool. Or we can just do something like string to unit to unit. Seems a little bit more readable, right? So we get the character right. We get it, and then we can just chop by another delimiter, which is the comma, right? We want to get the word, so we can just like string review type equal to as we chop C on the V by comma. All right, and we can then just kind of string compare it. So we need a function now, another function called what do we call it? maybe string sv equals and then we need a little bit of mem compare. I think we already have it, so mem compare our sv buffer for another buffer, basically this one and this one. Sv buffer, compare it with the other buffer, and how much we have the minimum. Min x. Oh, not really. Okay. We need the minimum. Sv count more than other count. Is that true? Well, in that case, we want other counts to be returned. Otherwise, we want sv counts to be returned, or size, I guess. Size in our case. Other the buffer. Alright, and that's our basically mem compare, and that equals 0. That's it. We have if sv equals type with sv string. Can I get it? Because I'm a little bit lazy, right? So we can just string the view, or maybe we can just do something like blue. I don't know. We can just define something like blue view. That's going to be equal to, or just frick it. Sv string inline string view sv string sv, and basically the buffer, and we can just return length of buffer, and also string view dot buffer equal to buffer dot length equal to that. Length, size, count, a lot of other stuff to take. Sv string, right? So we do sv string with blue. Then we just do, probably a better name would be blue max, maybe max yes. So basically blue max, and then blue, basically blue max is equal to if count greater than the buffer, the blue max. We can just do blue max equal to count, else if sv equals type with sv string red, then that means we need to return red max, right? So this red max else if sv equals, we don't really need to check it, but I'm still going to check it. Then green, it's green, max. Well, we need to kind of chop by function, right? Because it's, yeah, I just realized, whatever, I'm going to figure this out later. Then we can just do green max equal to count, and that's basically it. That's how we get the maximum. And we can even define some stuff, like define green limit 14, or what? What is it? So it was the blue limit was, so 12, 14, so it's 12 red, 13 green, and 14 blue. So that's 13, red is 12, and blue limit is 14. We can even line break this. Alright, and then we can do where is T? Possible 0 if blue max is less than blue limit, and green and it's actually has them in order, so it's red max less than red limit, or less than or equal, I guess, and green max less than or equal to green limit, and blue max less than or equal to blue limit. What can we do? Well, we can just do possible plus equals ID, and we can just do that possible. So possible. Alright, that's basically the entire idea, but in here it's not going to work, right? Because we want to basically just have a function like svchop by chop of, let's trying to be sv, and then a function that returns a character, or maybe it accepts the character and actually returns a boolean. I forgot how function pointers in C work exactly. It was, okay, so it was the type and then the function name and the return type. So it's like bool this, and then the function name as a pointer. So okay, that makes sense. And we can do basically compare. Compare some function. Chop off. So we basically need the exact same thing as chop, except instead of this body, instead of having like comparing it to C, that's actually would have been a major mistake on my part. Instead of comparing to C, we can compare it with the function. So it's compare. Comparison function. Compare. While comparing, while not compare, or maybe while it okay, and that basically just, now in here we can do chop C. Oh, it doesn't equal that. while okay, and now we can basically write a function that's basically just like that, which is called is terminating, or is lists is type int, which is a character. It takes in a character, and we can just return c equal to hash, or c equal to this. And now we just do is type int. So instead of chop off, we can instead of chop c, we can make this type int. In C++, it would be a lot easier because we would have lambdas, but I mean, it's fine. Yeah, it's actually chop of here. So it's chop of this term. How did I call it? It's type int. And that's it. Let's see if it works. Or it could be new line, right? So, or new line. Right, because in here it's a new line, right? And we can see, right, let's actually see if this works with this. A lot of errors, right? Let's start with the first one. So we need to include string of h. That's simple enough. And now let's run it. We need to include standard ball. Simple enough. Oh, you have a boolean though. Oh, let's actually clear it because the errors are a little bit cluttered. We need standard int as well. First include standard int. Assertion failed. SV size more than or equal to count. We at line 444. So maybe as we skip should be instead of that. SV size is less than, it's more than or equal to count, right? What do we do? If it's less than count, we can do basically count is equal to SV size, and that's gonna do it. Yep. Okay, that's weird. That's a bit weird. We can probably get the line instead, right? View line equal to SV chop C. New line, that's actually printf instead of that. It's actually printf the line itself. And to print it, I think the formatter was something like this, and it was line size, line buffer. And let's actually have this instead, and then slash new line here. Yep, and let's run it. Okay, I forgot to put a semicolon in here. That's it. Ein line. Oh, right, so we need to actually trim. Let's actually have, yeah, trim the line on the left and on the right. So we can just do as we trim, and as we trim, so it's a void trim, and reverse trim. So we have SV string view, and we just do SV while SV buffered 0 is space is white space, or maybe is space, well, it is a space, SV buffer plus equals 1, and SV size minus equals 1, minus plus plus. We also need to check that it's within the bounds, right? While and SV buffer and I is less than SV size. That's very important, by the way. Very important. Okay, okie dokie. And while SV size in the space, yep, I don't know what's more readable, probably this. We can even do SV skip instead. SV skip on SV1, right? And then we can do reverse trim on SV at SV size instead. At SV size, size minus equals 1. Right, we just want to lower the size, so we can just do SVR trim, and we can do reverse SV trim on the line and SV reverse trim on the line. We don't really have C type, right? That makes sense. So let's go to 0 and include that. SV trim. Oh, right. Let's go to at SV. Yes. So this is not this, but this. It is here though. But SV trim is implemented, right? So what's the problem? Okay, so that's interesting, right? So why does it do that? But they exist, right? This should cat main, see. Source main, see. It should have that, right? No, I need to do this. Maybe I need to do this instead. It's a little bit weird. List threads, that's agree. Okay. Okay. -1 maybe. although that wouldn't work on. Okay, that doesn't make any sense. What about without the reverse term? The reverse term is this /r, so we can just move this. So instead of that, right, -1. But that would mean if not as it says, we can just return. But if it was like at the end, it would also break. Or basically we can just do this and add this size plus equals 1, this size plus equals 1. That's it. And that's game 1. Yeah, and that's it. Now instead of V, we need to use line. Alright, instead of this we need to use lines. So V, in here we can substitute V. No, in here we can substitute V and V with and line. Line like this. And that's it. It keeps on going forever. Drop C. I can even log the line maybe. Line count to 1. Like this, so we do path, then line count. And the line is actually going to be this. Maybe line buffer, line count, line size, I imagine. And line count in here plus equals 1. Line count plus equals 1. Crashed. Oh, it's the other way around, so it's size and then buffer. That makes sense. Okay, way too many lines. Clear. We have a bunch of empty lines. If line, and we can even skip one as we skip for V. Skip one. ID is 0, right? So that's kind of interesting. So that's weird, right? Maybe our function isn't correct, right? Our string at uint. If not that, so it's if it's less than or equal to this, or it's more than or equal to more than that. If it's less than this or it's more than that, we can just return it. Yes, that's our issue. I don't want 150 for some reason, which is not correct. I don't think it is correct. 8. Let's actually log the ID again. Def ID. We can even do something like ID blue max red max. Red, green, and blue. So RGB. Green max zoo. Alright. It kind of makes sense. So it's red max, green max, blue max. Alright, and let's see. Alright, we have ID of 10, which is not correct at all. While size, get the character at 0. That would be what? What does the string to uint get even? Okay. So get the character at 0. And then plus equals C minus that makes sense. Oh no, that's not correct. It's actually the exact this, so it's, yeah, now it would be correct. Now it should be correct. It says 15 for some reason. Maybe because red, blue, green, and blue are incorrect. Right, yes. So if else f standard error found other dot this s, and we can just do type size type buffer found other, and we can just return error found other error at this line found other. So we can just do buff and then line, so it's easier to actually read it, right? So do line. Okay, and this, by the way, is just the first part of the challenge, right? So we didn't get any unexpected one. Ooh, okay, so first issue is this. Okay, so what do? We do. Oh yeah, we did this for just one of them. So actually, if we check this out, for example, blue on this one should have. No, it doesn't. Okay, so the count is 0. Interesting. Count. Send D or U count, right? Count is 0, right? Let's actually put the line like now. Line maybe. Undo. I said line. This after we chop it. We can even remove line. Just this. In loop. Loop, I say, even though it's not actually loop. Okay, so it's 3 blue, 4 red. Well, makes sense. It skipped it. No, it didn't. Oh, right, that makes sense. Okay, I know why, I think. So we need to skip the space or whatever character came before us. Then skip the next one. Actually not, probably just skip the previous one and then yep. 3, 1, 8. Yep. Now it works. And we can do while line size to this. 8. Exactly. So now we just use the bigger data. Let's actually comment this out so it's not logging the entire thing. Alright, let's run it again, that's 8. Even though I leak the memory, right? We leak the memory for the buffer, that doesn't really matter. But if we get our test data, our actual data, right? So we can paste this in here. Okay. I just want this. 3086. 386. No, that is it's too high. If you're stuck, make sure you're using the full data. Interesting. Is that actually everything in here? Alright, so maybe we don't parse it correctly. Not quite sure. Right, so I'm gonna complain about finding any other ones. Maybe it's not equals. What the answer? Oh, no. It's equals as well here. Right. First one. What did you get as a different answer? No. Even this one in game. Come on. We don't parse the next ones. That's interesting. That's very interesting, actually. So, we only parse the blue. Okay. Let's check out what happens in game 1. We get here. Really? That makes sense. But why is it only for the blue? Huh. That's very interesting. All right. As we chop off. Okay, blue, red, green. That makes sense. Red max. Okay. All right. Oh, okay. So, for example, look at this game. Right. Yeah. Okay. Okay. We need to get the game now that we have the line. We have the line, we have the ID. Now we need to get the game. Game equal to as you chop C of the line, which is by this. It's either going to chop that or going to do this. This is C, and then wire game. Wire game says. Yep. And the one, it's game. Okay. And now do we get anything else? We're stuck. Probably because we need to do as we skip on the 901. Maybe not game, I should probably name it something like for probably set. Yeah, makes a little bit more sense. Okay, set, while the set is there, drop it off by that. And we can do collect the count, so we just do count. Size the blue count. Red count. Count 0. Size the green count. Count equals 0. And we just do green count. Count plus equals. Now just green count plus equals that. Red count plus equals this, and blue count plus equals this. I misunderstood the actual assignment, right? Which is kind of bad. Okay, we got it. This is a little tougher than I thought, right? Maybe because it's C, but and because we don't really use any external tools. Well, we could have, but it's fine. I don't think it's too bad. And once we're at the end of the set, what do we do? Yeah, we need to close off the set. Right, once we're at the end of the set, okay. Oh, what? No. Once we're at the end of the set, we need to compare the blue max. Max if blue max less than blue count, blue max is equal to blue count. We'll play this in here with substitute blue for blue underscore SI. No. Substitute blue. Okay, you can't really do that. Okay, that's blue. That's red. Red count. Green and blue. Oh, right. And that should be it. Right, let me just indent it correctly. Okay. Basically it. Now it's even more for some reason. Weird. That's really weird. It's almost like it doesn't even parse it. We can do some like printf count type. Count and then type size, type buffer, and then slash new line, of course. Well, now we can get that count, not count, count. And let's actually break on one, right? Once we get the first one, turn one. Oh! It's not this. Other size. That begins with. Yeah. SV size. If SV size doesn't require SV buffer, just return prematurely. The false automatically. The other size. Okay, so we need to kind of skip as we skip on the set. One. We try to skip one, and then we get to the end. Counter. And let's do counter. Counter size, counter buffer. Wow. Okay. It's green, comma. Huh? To the game one, it parses this, and then the green, comma. I guess it's not that. Let's type in, there's a, with, as we chop off. It's step in, right? Oh. Oh wow. Okay, that's just dumb. Space green, right? Yes. Now we can skip. And now it should work fine. As we skip on the set one. And then we need to skip. Have to skip one. Not comma is holding it. Now that gets the type. What? Right, so that's the maximum. The count intensifies as time goes on. Yes, that makes sense. Cool. Right. We should add them together, right? Add the counts together. And okay. Okay, that makes sense. Alright, so we basically add them up, right? And if it's possible, why does it help though? On look, it helps because it's trying to find space and there's no space. Maybe let's skip the character, right? The count is per set. Okay, all right. Let's rethink this. So get the line. That's the entire game. So we get the entire game. So this thing goes back to 0. So this thing, we get this from here to here. All right. And then we get this, which is that we call a set. And each set has its own size, right? But let's set buffer I at 0 does not equal this. Okay. Why does it get stuck again? Where could it get stuck? But that's it, right? We can even do something. It gets stuck here. Then zoom. That's 0, right? And then in here we can skip on the line 1. We don't need to skip this. We can just skip this automatically. Yup. Game 1, red max. No, that's definitely not it. So yes. Okay. Right, delete this, paste it here, at the end of the set. Parsing. Blue max is 1 for some reason, and blue count. Let's actually also print the blue count. Blue count. Red count. Isn't here. Why the fuck am I printing it like this? Okay, it's a red count. Percent U. Your green count. Percent U. RGB. Right. I'm just getting a little tired. Right. Green count and blue count. Come on. And we can even log it afterwards. After we already have this. So just do this. Why does it do that? Plus equals count, right? That's the idea. SV equals type SV string blue. Okay, blue count plus equals that. Why would it get preset though? It doesn't make sense for it to get preset. Unless we do something with it. Okay, what do we do? We do count is 1, count is 4, right? So 1 is green, and then green count is 1. Before that it was 1, that was 0. Then next blue comes around and overwrites it for some reason. I clearly state in here, okay? I clearly state, okay, you use, you add it, this, you, okay? I clearly say that, right? Count, plus equals count. I think it's time we should actually pull up GDB, because that's our best option, I think, in this case. Source, open the make file. Let's actually edit the make file. Let's actually have a debug one. It's essentially the exact same thing. Just that it's with these symbols and this. And debug. Let's actually run debug. What is happening if I run it in debug? Okay, so that there's something really wrong with my GCC. Okay, void. Maybe let's just remove the inline on all of them. That could work. Okay. Oh, right, yeah. Okay, I already know what's going on. So we need to actually... Alright. Sense. Yes, okay, so we need to do SV trim on F. Yes, yeah, V. That's the first issue. I see. Even though we do exit out of them. Would it be a case of overflow? I'm not sure. GDB - terminal UI out main break main, and let's run. Next. Let's actually get sprint buffer view buffer. Okay. Next. Let's actually print line. Next. Print ID. Makes sense. Next. So we just do print blue max, print red max, print green max. Okay, those seem fairly normal. And we get the sets. Blue count. Next. Print count. It's green. Next. This logging could be an issue. Actually, yes. It resets for some fucking reason. Type. Chop off. Right. Well, I is less than SV size. Buffer at I. SV skip I. Why though? Right? Why? Why would it? That doesn't make any sense. That's really weird, right? String to you and y of v size. Atrim set is type end. Type. Okay, we print the type in here, maybe. No. I don't see the problem here, honestly. Oh no, that makes sense. That makes sense. That makes sense for it to be like that. But this doesn't. It should be checked in here. Yes. But why does it... Okay, at the end is 4. Oh my god, dude. Okay, now it works. Now we can test it on the entire shit. And it should be fine. Okay, let's see. Do we get the possible result? No, we're done with 1 because it's in here with 1. Yes. So, yeah. 2486, and that should be basically the answer, finally. Okay, that was just being stupid. I guess we're doing part 2, but I've already been recording for like an hour and 40 minutes, and I almost feel like we need to take a little bit of a break, but we'll check this out, and if anything, I'll probably just end up splitting this into a separate video, right? The elf says that they stopped producing stone because they aren't getting any water. He isn't sure why the water stopped, however, he can show you how to get the source water to check if it for yourself. It's just up ahead. As you continue to walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in one bag in a game possible? The fewest amount. In game 1, the game could have been played with as few as 4 red to... Yeah, I can do that. The power of a set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. The power of the minimum set of cubes in game 1 would be 48. That makes sense because it's 4 times 2, 4 times 6, which is 8 times 6 or 48. In games 2 and 5, it will be 12, and respectively adding up. These powers gives you this. What is find the minimum number? Okay, and just a little bit more. Alright, we got a little bit more. To go, min, and instead of that we can just... Okay, let's actually pick this solution. Probably put it in its own type of, like, a function like void solution 1, which should just take in the buffer rate, or maybe just the string of u, and you do this, and yeah. And that's basically it, right? So we can do even solution 1, right? We can just do root solution 1 with v. And now if we run it, return 1. Where do we return 1 exactly? Path. And we can just exit with 1. Exit with 1. Okay. And also path. Path and then v. Yep, that makes sense. So basically, that's our solution, right? We get the exact solution for it like we did before. So now we can just get another function called string view, probably like solution 2, that's taking the exact same parameters, probably path and then string view, and that's basically it, right? We just copy the solution, make it, paste it into here, again, just place this here. Okay. Now we gotta log the power, maybe power, and what did we get? What is the sum of the power of these sets? So we can do, instead of possible, we can do power, right? Blue max, red max. It's actually going to be blue min, red min, and green min, and that's going to be 0x FF and 0x FF XFF. That's it, and we can even double it, because why not? Because it's 1, 2, that's 4 bytes, and this should be 8. Right? If we select this should be 16. And it is, right? It's 16. So that's our minimum. Basically, you set it to an absurdly large value, and then just do, if it's more than that value, set it to that value. And that's actually going to be minimum, right? Instead of maximum, it's actually going to be minimum. We need to find the maximum win that game. Or actually, no, right? We need to find the maximum within that game. The max needed within that game, that makes sense. So let's actually trace back a little bit. Yep. Get the maximum within that game. And then the power would be, for this set, for this game, the power would be equal to the red max times the green max times the blue max. Probably would be a wise thing to do is cast it to size t, so that way it's a bigger number, right? It has 64 bits, kind of stuff. And now we just log the power, and that should be solution 2, I imagine. It's the same input, hasn't changed, of these sets. Okay, blue max, right? Because I renamed them, so it's max, and max like they were before. And how do we get? 8700,984, and that's the second one. Right, that's day 2 for you. If you are enjoying this, consider subscribing, leaving a like, and leave a comment. Tell me what languages I should add to the wheel, since, yeah, it's a lot more fun that way. This episode has been a little longer than the others, so I'm probably going to end up making it a compilation, but yeah. See y'all in the next video. Bye!